Hi, everybody. My name is Mr. Geiselman, and welcome to our first day back in person learning. So this is your first assignment for at night. This is the electromagnetic spectrum ed puzzle. So let's get going. So what is the electromagnetic spectrum? I know we talked about it last unit, but a quick review is the electromagnetic spectrum is a series of different wavelengths of light that do not require a medium to travel through. So they are waves that do not require a medium. A medium is something like a solid, liquid, or gas. So these are light waves that can travel through space. They consist of electric and magnetic fields interacting. And all of the different types of light that we're going to talk about are examples of the electromagnetic spectrum. They all travel at the speed of light. You've probably heard of light speed and light years. Well, light speed, or the speed of light, is really, really fast. 300 million meters per second, right? So that's a really, really fast speed. And when we look at the electromagnetic spectrum, we range all the way from radio waves to gamma rays. So that whole spectrum, that whole list of them, is what makes up the electromagnetic spectrum. Here it is a little bit more blown up. We can see that our radio waves are going to be much larger wavelengths. So radio waves are 10 to the third meters long. They're very long radio waves. So they don't have a very high frequency because they're still traveling at the same speed as our higher frequency waves. As we move down the spectrum to microwaves, infrared, visible, ultraviolet, all the way to gamma, we see that our wavelengths are getting smaller. And because our wavelengths are getting smaller, our frequencies are increasing. So as we go from left to right, we see that the frequencies increase. And as we'll talk about later, frequency does affect the energy of the wave. So that EM spectrum is the complete range of electromagnetic waves. It includes everything from radio waves to microwaves, infrared, visible light, ultraviolet light, X-rays, and gamma rays. Those are all of the different types that we're going to talk about. We're going to break them into three categories. I'm going to call them the low energy waves, visible light, and then the high energy waves, which are ultraviolet, X-rays, and gamma rays. So the EM spectrum is separated into categories based on their wavelength and frequency. The farther to the left on that spectrum, when we looked at the picture, the longer the wavelength and the smaller the frequency. But as we continue to move on, they get stronger and stronger and stronger. The frequency gets higher and the wavelengths get really, really small. But it does not matter that any of them are that they have different frequencies or wavelengths because they all travel at the same speed. They all travel at that same speed of 300 million meters per second, or the speed of light. In the equation E equals mc squared, c is that speed of light, and that's the number. So c is equal to 300 million meters per second. When we look at the low energy waves, they are waves with low frequencies and long wavelengths. They are inverse. So if it has low frequency, it's going to have a longer wavelength. The lower frequency waves have low energy, and these do little harm to living things. This is why it is not harmful for us to have a radio wave actually pass through our bodies. Microwaves are used in our cell phones. This is why it's not dangerous to us. And infrared waves are used in lots of different things like remotes and sensors. And this is why it's okay for us to be around them, is because they don't have enough energy to really harm us as living things. Radio waves are obviously great for communication. They can carry information over long distances, and they do not harm living things that they interact with. Microwaves are also great for communication. Your cell phone and many satellites use microwaves to communicate. They're also used for several other things, and obviously heating things like in a microwave oven. Remote sensing, a lot of different things use microwaves to actually send signals. Radar is another example of that. Infrared then is a little bit stronger. It's a shorter wavelength and a higher frequency than microwaves or radio waves. They're also really great for heating. So if you go to a cafeteria and you grab something underneath a heat lamp, it's using infrared heat. It's also great for remotes and other sensors. And even some imaging technology, like in a medical setting, would be using infrared. That brings us to our next category, which is visible light. Visible light is very special because it's what you and I can see. It's a very small section of the electromagnetic spectrum that our eyes are specifically designed to detect. We can't see microwaves or ultraviolet light, but we can see the brief wavelengths that make up visible light. So the rods and cones in our eyes are sensitive to wavelengths of light between 740 nanometers to 380 nanometers. That ranges from red all the way down to violet light. And NM there stands for nanometers, which is 10 to the negative 7th meters. It's a very, very small wavelength. Visible light follows the order of longest wavelength to shortest wavelength. So we start with red as the longest wavelength, lowest frequency. Then it goes orange, yellow, green, blue, indigo, and violet. You might notice those are the colors of a rainbow. And this is exactly why they separate into those different categories or those different bands in a rainbow. So if we look at a rainbow starting with violet on the high energy, high frequency, low wavelength side, we see that the shortest wavelength starts over there in this corner, right, with violet light, and it actually goes to the largest wavelength on the other side in the reds and the orange. If we look at the lowest frequency, that starts in the red spectrum. So the more red a color is, the lower the frequency is going to be. That's also going to move towards the right here or towards violet light as we increase the frequency. So the highest frequency is found in violet light. That brings us to our high energy waves. These are the waves that have low wavelengths, so they're very, very small wavelengths, but they have high frequencies. So high our eyes can't detect them. They do have enough energy to harm living things. And one of the things they would do was they would mess up the DNA or mutate it and change the DNA within your cells. This causes problems with your cells copying themselves. It causes problems with them creating proteins. And if the cell doesn't die from this, a mutation can actually be very, very dangerous to us. UV light, X-rays, and gamma rays make up this portion of the EM spectrum. UV rays are used for remotes and sensors. It's also the stuff that's going to give us sunburn. So if you are one of those people in the spring and in the summer, you go outside and you're outside for a little bit too long and your skin starts to get red or you start to burn, that's because of the ultraviolet light or rays that are actually killing cells in your body. The red cells are now dead, and that's why you'll end up peeling from them. UV is bad for our skin in large amounts because it can cause mutations that lead to cancer. And obviously, cancer is a very nasty problem for us. X-rays are obviously used in medical imaging and therapies. If you break your arm, they will take an X-ray of you. But they'll often use a protective lead apron to cover the parts of your body they don't want to take X-rays of. That's because overexposure to X-rays can mutate DNA and cause cancers. Now, if you go into the doctor and you take a couple pictures of your arm, a couple X-rays, that's not going to be enough exposure to cause problems for you. But there are some instances where people who work with X-rays a lot can be overexposed and develop cancers because of it. Gamma rays then are the most dangerous. They are very dangerous to living cells. They can kill and mutate DNA easily because they have the most energy. They have the shortest frequency and the most energy. So they are very dangerous. And one of the things that they're actually used for is to sterilize medical equipment. This will allow them to, or a medical team to They'll wash their equipment and then they'll sanitize it. But this process of using gamma radiation will kill all living cells like bacteria and even denature the proteins that a virus would need to replicate. So it kills all of those different things. It can also be used for very aggressive cancer treatment. If they're trying to target specific tumors, gamma radiation can be used to help cancer patients. But it's a very aggressive form of therapy, and this can easily cause cells to die or cause DNA mutations that can either lead to cell death or to cancers. So that is about it for the day. If you have any questions, please reach out to Mr. Oleg or I. We're looking forward to seeing you in class tomorrow. Thanks, everybody.